So trig substitution is actually more difficult in the algebra part of things than in the trigonometry part of things. The idea here is that you're given the substitute. You're told that x equals this. And then you're told you have this expression, but they don't want the expression with an x in it. They want the expression to have a theta in it. So what you're going to do is you're going to say, well, if x equals this, so it equals this, then I'm going to take that and plug it in for x right there. So then we rewrite it, square root of 4 plus, and instead of the x, we're going to put 2 tangent theta. Square that. Now that's just the first step. Of course, now we're going to simplify this. For instance, we have these things being multiplied, so I'm going to distribute that 2 to both of them. So now I have the square root of 4 plus, well, 2 squared is 4, right? 2 squared. And then tangent squared is tangent squared. Now, I know it's really tempting, but you cannot do this. We have a square, we have a perfect square, and we have a perfect square. So it's tempting just to square root, square root, square root. But the problem is this guy right here. We have a plus. We cannot square root unless it's all multiplication. So we're going to try and make it that. You'll notice that this term and this term both have a 4 in it. So I'm going to take out a 4. And when I take it out of here, it's like I divided by 4. So 4 divided by 4 is 1. And then when I take it out of here, it's like I divide by 4, so the 4's are gone, and I just get tangent squared. Okay, now, go back to our trig identities. Hopefully you identify that 1 plus tangent squared is secant squared. So now I have the square root of 4 times secant squared. Hey, and guess what? I have now all multiplication. This is all multiplication, so I can square root, and I can square root them separately. The square root of 4 is 2. The square root of secant squared is just secant. And now I've rewritten it. There's no more square root. Not that you have to get rid of the square root, but you can, so you should. And then I have just a theta. I don't have an x anymore, so this would be my answer. So let's try another one, just so you get the idea of this. All right, so here I have my substitute is right here, and I'm going to plug it in for the x right there. So I have the square root of 64 minus 16 times 2 cosine theta, all being squared. So the only thing different is that I put that in for x. Excuse me. And then I got to do my math. This is all being multiplied, so I can distribute the 2. So now I have the square root of 64 minus 16 times 4 cosine squared. And then I do whatever math I can here. I can multiply all this together, which means I multiply these two. So now I have the square root of 64 minus 64 cosine squared. Once again, it's tempting, isn't it? It's tempting to square root these things, but I have a minus sign, which means I can't. So then I notice that I have a 64 in both of these, so I can factor that out. So we take out a 64, and now I get 1 minus cosine squared, because that's what happens when you factor out a 64. And 1 minus cosine squared, that seems familiar. Well, if you remember, sine squared plus cosine squared equals 1. So if I subtract cosine squared from both sides, sine squared equals 1 minus cosine squared. So I can replace all of this with sine squared. So this now equals the square root of 64 times sine squared. And now that I have perfect square, all being multiplied, I can actually do the square rooting. Square root of 64 is 8. The square root of sine squared is sine. The only thing more I can tell you is if you have the square root of, let's say, 50 sine squared at the end, and you have to simplify that, you can square root the sine squared, but don't leave the 50 alone. See, the 50 is really 25 times 2. You can square root the 25, you can square root the sine squared, but then you're still left with the square root of 2. So maybe I would rewrite it. I would have 5 square roots of 2 sine theta. That was maybe how I would write that one. But it is possible that you're still left with the stupid square root in there, but that's okay. You simplified everything else that you can, which you should. All right, good luck.